Welcome back to the deep dive. Today we have a really specific piece of hardware. You sent us the tech sheet for the NTI E-SLDO-IP68. That's the Submersible Spot Liquid Detector.
It is. And our mission today is to look past the specs, the numbers, and really get into what this thing does. We're talking about preventing some pretty major failures.
Right. And the big question here seems to be about catching leaks in places you just can't see. I mean, think about the space under a giant industrial air conditioner or behind a server rack.
That's exactly it. How do you stop a problem before it turns into a full-blown disaster? So this device, the E-SLDO-IP68, it's built to find conductive fluids.
Water, basically.
Mostly water, yeah. And it does it in these really cramped, inaccessible spots. The sources list places like under commercial dishwashers, washing machines, that kind of thing.
But the one that jumped out at me was electrical switchgear rooms.
Yeah.
That feels like the highest stakes.
It absolutely is. A little bit of water on the subfloor. There isn't just a puddle. It could short out the power for an entire building.
Okay, so you mentioned it targets conductive fluids. I'm curious about that. Why is that distinction so important? Are we just ignoring other kinds of leaks, like oil?
So that's a great question. And it's an intentional design choice. In these settings, especially with electronics, water is the #1 enemy. It's what causes the shorts, the corrosion, the big dollar damage. So while, no, it wouldn't catch certain oils or coolants, it's hyper-focused on the most probable and destructive threat.
I see. It's about playing the odds. And the precision on this thing is frankly what I found fascinating. It can detect a fluid level starting at 0.03 inches.
Right, which is just, what, 3/4 of a millimeter? It's almost nothing.
Exactly. This isn't waiting for a puddle. This is catching the very first sign of a drip.
And that's the whole engineering philosophy behind it. By the time you can see a leak or a normal float sensor goes off, you could already be looking at thousands of dollars in damage. This gives you a heads up, maybe hours, even days, before it becomes a real emergency.
And to do that, the device itself has to be incredibly small. The specs say it's roughly 2 inches by 4 inches.
And less than 1/5 of an inch thick. You can pretty much stick it anywhere with an adhesive strip or a tiny screw. It just disappears into those tight corners.
So, given that you're putting it exactly where water is supposed to go in a failure, how tough is it? What's the durability like? I saw it has an EMA 6P or IP68 rating.
And that rating is everything. That IP68 means it's not just water resistant, it's fully submersible. So if a pipe does burst and the whole area floods, the sensor doesn't die. It just keeps on signaling that there's a problem.
Okay, so it signals how?
2 ways. First, there's a simple visual cue. A red LED lights up on the unit. But the real alert system is through what are called DPDT alarm contacts.
DPDT. For listeners who might not be in the industrial space, can you break that down?
Sure. DPDT stands for double pull, double throw. Think of it as a heavy-duty redundant switch. When it detects a leak, it flips 2 separate internal switches at the same time.
Ah, so you can have it do 2 things at once.
Precisely. You could have it trigger a siren in a control room and simultaneously send a signal to, say, shut down the power to that HVAC unit. It ensures a fast, coordinated response.
That redundancy makes a lot of sense for critical infrastructure, and I saw it connects with a standard cable to NTI's monitoring systems. It also mentions that it's TAA compliant.
Yeah, the TAA compliance is interesting. It basically means it's approved for U.S. government contracts, so you know it's built to a certain standard and has a reliable supply chain. It's not just a consumer-grade gadget.
So to wrap this part up, we're looking at a tiny submersible detector. It's a perfect example of risk management, really, protecting huge, expensive assets with millimetric precision.
It really is. It's the silent guardian in the machine room, just waiting to catch that first drip before it costs a fortune.
So we've looked at this one very specific sensor, designed for conductive fluids, built to survive a flood and signal an alarm with this redundant system. It got me thinking. Considering that level of durability, the IP68 rating, and that dual signaling DPDT system, how could that same core technology be adapted? I mean, for really long-term remote monitoring. Think of deep-sea energy pipelines, or maybe even unstaffed research stations in the Arctic. That's something for you to mull over until our next deep dive.